So what's going on there? Well, uh, and there I'll tell you about a discovery made by another student. Undergraduate students are amazing. Sometimes, they're they're so creative. They'll do anything. Hey, I'll try this or I'll try that, and I encourage them. Always.
Happy accidents, I think, is how you term that, Gerald, if I remember correctly.
It was a happy accident. Yeah, it was an accident because this particular student, uh, I assigned, well, I don't usually assign. I discuss a few possible projects, and the student chooses what the student likes to do. It works best that way. So, yeah, happy accident. So I asked him. We had just we have just found that the polymer naphthalene, which we had been using quite a lot, we've been using sheets of naphthalene, and we just found out the naphthalene also comes in tubes, like a straw made of naphthalene. So I asked the student, I said, we know that a flat sheet of naphthalene grows EZs very nicely, but if it's curved, as in this tube, does the curvature impair the ability to grow EZs? So he did the experiment, and he quickly found out no problem, lots of EZs in there. And I was away on a trip somewhere, I don't know, Europe, whatever, giving lectures, and he'd already solved the problem. He answered the question, and I wasn't there. And he thought, okay, well, I got to do something. So he started doing experiments on his own. And one day, when I had returned, I was sitting in my office with a visitor, and the visitor was maybe less than compelling. And I was sort of hoping the meeting would end. And fortunately, this same student barges in, and I pretend that I'm irritated because, he barged in and I'm speaking to somebody and he shouldn't interrupt that way. But he said, I got something I thought you'd want to hear. It looks pretty interesting. Okay, so tell me, what is it? I was actually delighted that he interrupted the conversation, but I didn't.
I love it.
I didn't want to demonstrate it. And okay, anyway, he said, I looked at the tube of naphthalene, just like a straw, horizontally situated in the chamber, covered by water. And he said the water kept flowing through the tube from one end to the other, and it wouldn't stop. And he said, I thought it was pretty interesting. I wanted to tell you that. And so I thought, if this is real, and we quickly confirmed that it was real, is really important because it would seem usually what you need is a pressure difference, a pressure gradient from one end of the tube to the other. But this tube was just lying in the chamber like this, water equal height above both ends of the chamber, and it just kept going. And you need energy to do that. So where does the energy come from? We had just found that about the infrared energy. And I know infrared energy is coming to the chamber. It gets absorbed because water loves to absorb infrared wavelengths. And that energy was getting transduced by the water into something that produces flow. And we began to understand exactly what the mechanism is, but it had something definitely to do with easy water and the separation of charges.